Welcome back, Science 7. Let's get today's lesson started. Before we begin, I ask you to do science log activity number 7, which was about why is it relatively easy for us to predict volcano activity than earthquake activity. Even though there can be different answer, but again, my example, if you like to know, is because when it comes to volcano, we already know the location. So I like to say locations are predictable. And those are the one that you can think of. Volcanoes that is under sleeping, which is dormant. Or when it comes to volcanoes, it is located near Pacific Ocean plate. So you can predict where things are happening. For example, it can be Hawaii, or it can be Fuji Mountain, Japan, those kind of things. On the other hand, when it comes to earthquake, ladies and gentlemen, earthquake can be a little bit tricky because earthquake happen due to collision between plates. So that means even though we know where the plates are located, we need to monitor how much it moves and which direction that it moves and so on. Plus, we need to think about how focus will play a huge role when it comes to any type of earthquake activity. If you guys remember, focus is a place where the impact is happening. So that means we need to locate epicenter, which is the one that is located right above, and so on. Which we need to do ASAP, but at the same time, wave travel faster in solid. So these are my example answer. So let's get this thing started. Today, and starting today, if you will, we are going to explore something I like to call incremental change. Incremental change is regular increase, actually. You can consider that as gradual change if you put it as an easy way, because gradual change are slow changes that occur and it kind of stack up as time goes. For example, wind, changes done by wind, water, and ice. We call it erosion, which we're going to see later, but just know the fact that we're now focusing on the gradual change. There are several changes on Earth. This is a little recalling. Sudden and dramatic changes are happening because of the plates movement and magma activity. So, first thing first, we'll learn about earthquake and we'll learn about volcanic activities. On the other hand, gradual changes always happen, but it's done by small forces. What I mean by that is, like I said in the title, wind, water, and ice. So if it's done by any of those, there's something I like to call weathering effect is happening. There's also something called erosion, and there's something we call it deposition. So let's look at our first part. What is weathering? First of all, weathering is a fancy way of saying things are break down and things are wears away. So the key highlighting parts that I like to make is wearing away. You have an experience probably that if you wear your clothes a lot and then if you wash it constantly, what happened to the cloth logo at the front or back? They actually start to worn off. Think about that way. It wears some of those structure that is solid away with the long period of time. And by doing that, land will have sediment layer, which we're gonna see more. So there are three types of weathering. Number one, mechanical weathering. For example, this is the one where waters, constant rain hit the surface of the rock and rock actually becomes smoother, something like that. There is something called chemical weathering. This is the one where, for instance, metal turning into rust. And biological weathering, this is the one where sometimes you see it in the mountain, not necessarily a lot in Alberta per se, even though I saw some when I was doing hiking. Randomly, you may see that a big tree is growing on from the rock. So the root is actually going into the rock. So we're going to look at those as an example. First thing first, let's look at mechanical weathering effect. Mechanical weathering is a physical weathering. It's just a fancy way of saying you have a lot of friction, if you will. And friction is any motion that opposes whatever the motion. So for instance, if you have wind that is passed from west to east in this diagram, while it's go around the slope of this badland structures, you will notice that the friction is happening opposite direction. While doing that, we have a break in terms of rock or sediment structures, and it is not a big force, to be honest. However, it's constant long period of time effect, so have that in your mind. So physical forces such as water or wind often blows strongly, and it can pick up a lot of dust and grit and bombard it. So when it comes to this one, I want you to think about your life experience, and it's quite common. Highway and chips on a windshield. You have that experience. Sometime, most of the time to be fair, it is done by a big truck or big rig that is passing next to you, or you're passing the vehicle, and there's a gravel that actually get reflected by the motion of the vehicle, and then it hit to the car that is behind you. That is very common, but sometimes wind can pick up some of those gravel, dust, and so on, and it actually can hit the surface of your windshield. So that can be another one. And rock is often broken down by water, freezing and melting in cracks. This happens notoriously a lot in Alberta when it comes to two seasons, spring and fall, autumn. But most of the time, springtime, it happened dramatically. So what happened is basically raindrops happen on the surface on the rock, and then there is a moisture happen. But during a winter, these guys start freezing, and when it comes to freezing situation, water's volume expands. That's a fancy way of saying the volume is actually increasing inside of the rock, but the rock doesn't change its volume. Because of that change in volume of water, it actually cracks. So I like to say, when it comes to this one, water turning into liquid to solid, the volume goes up. That's why we start to see cracks. And gravity also can disintegrate rocks. Like I said, a lot of raindrop, if it's a heavy rain season for a long period of time, even though it's a yearly based season, you're gonna have a smoother surface of the rock. Like I said, mechanical weathering, like the word suggests, it wears away materials that you can interact outside. So it really wears away the surface. And sediment sometimes builds up because of that. And I want you to look at the diagram on the right side of this PowerPoint. On the left side, which is what you can see over here, there is no rain, precipitation, wind. It doesn't play a huge role initially. But when we have a lot of precipitation, in this case water and wind, can you see it's going sideways? Because of that process, there will be a broken down structure at the top, and then some of those gravel goes down, and then sediment will happen at the bottom of the surface because of gravity. So first, I want you to copy it down. Weathering causes the rocks to break down. And once we call it erosion. Erosion by water happened, then transportation happened at the higher up to midpoint of the mountain range or something like that, and these guys go downhill. And when it comes to sediment, they occur at the bottom of the surface. And generally you're right, under the lake, under the ocean, it can be many type of application like that. But right now what is important is sediments are the one that work like a sandwich. So old sediment goes down, the new sediments are the one that stack up. The next one that we're going to focus is something I like to call as chemical weathering. Like what you see on the picture, right side we have a pure iron, on the left side we have rusted iron. So how can we understand the interaction between those two? Everything has to be done with the metal. So we're going to focus on mineral portion of the rock. Minerals present on Earth's surface or atmosphere can dissolve in water and react with oxygen. So two things. I want you to highlight water. Minerals are dissolvable in water. And it doesn't stop there. They react with oxygen. If that happens, we call these two combined together and name it as corrosion. It happened to all of the metal except one metal, and that metal is gold. Gold do not get corroded by oxygen and water. But most of the other metals like copper, iron, nickel, any of those guys can actually get corroded. And corrosion means the chemical component change. It's a chemical reaction, and it turns completely into different chemical. The one that you see over here, the red rust, those are irreversible form of iron. You need to do something I like to call electroplating and so on to prevent that. Or you need some kind of reverse process to make it refine as iron If you want to know a good example, I like to go through Statue of Liberty. The one that you don't know is when France gave USA the gift of Statue of Liberty back in 1800s, the structure was actually a copper. As you can see, because it's copper, you have red, yellow type of a color. But the one that we see nowadays is completely green. So a lot of people thought is Statue of Liberty is actually green. No, it's not. If you want to know what happened, unexposed statue look like this, but as time goes, the color fade out, and change completely into what I like to call copper oxide. Those are, imagine a rust that is growing on copper. I personally like this color better though. Chemical weathering can play such a huge role for any type of statue too, especially if it was made out of limestone and so on. Before I go through, I want you to focus on the picture on the left. This was what it should be originally kept as its shape, but after decades later, look what happened to the face, arm, and so on. All of those are weathered away because of acid rain. So new minerals are often softer and can crumble because of the chemical reaction. So it happened quite dramatically on the surface first, because chemical reaction always happen with a surfacing area. So some of the gas that is in the air combine and become worse chemical, which is known as acid rain, acid snow, and they completely dissolve mineral like how normal acid does. Biological weathering is the next type, ladies and gentlemen, but the picture explained to you way more. I want you to focus on the diagram that you see in this, or photography if you will. Can you see that there's a strong roots that go into the rock? And when it comes to this situation, it's even worse. Some of the roots actually go underneath and right adjacent to the rock, but the body parts of the woods is actually going in between of the rock on the left, rock on the right. So it's kind of like a sandwich situation. So it is done by living organism. One can be plants, and that's obvious. Another can be done by animals too. Like for example, when it comes to bird feces, it actually includes quite some acidity inside. So it's a little bit acidic because birds do not do number 1 and 2 separately, they combine them as one. Some of them bacteria does play a huge role because some of the bacteria disintegrate the mineral structure, and fungus. Plants, roots, and acidic fluids produced by roots can cause chemical reaction. And like I said, when it comes to most of the acid, they generally react with mineral and they convert the structures type of it. And if there's a new structure coming out after the chemical reaction, they're quite weak. And bacteria, fungi, and some insects and small animals can cause chemical reaction, whether they intended or not. The other parts that I'm going to go through is some process called erosion. Erosion is done by movement of rock and mineral that gains from one place to another, generally transported by water, but air can be the one too when it comes to desert. Water is, like I mentioned, one of the most powerful causes of erosion because they carry the minerals and other particles from one place to another, done by river, done by rain, done by ocean waves. So if you look at the effect of moving water, water can actually carry some light material, sometimes known as silt, sand, mud, gravel. Those are the ones that can be moved from upper stream to lower stream. And while they move side by side or carry down from upper area to lower area, we create something I like to call sediment. Sedimentation is a process. It's basically depositing the layers of rock and minerals, and you find most of the deposited layer at the bottom of ocean, lakes, and river. The next is a science log activities. I want you to do this as a homework question. So what does moving water do? Well, long story short, moving water can create bad land. The one that you see in Grand Canyon, and the one that we have, Drumheller, even though it takes million years to go from one stage to another. Running water create fluvial landform. So first thing first, waters always go left, right situation, and that's what the river does. And the reason that this kind of movement happen is more related to torque, because anything that turn around from inner corner is faster and stronger than the outside. Oh, sorry, I reversed it. Whatever go outside is stronger, whatever inside is slower. That's how the momentum works. But in any case, right now, just know the fact that landforms are created by running waters are known as fluvial landform. An example that I wanted to mention is any type of badland of southern Alberta. You can kind of see that when you pass Highway 60 before we getting into the bridge, or after, depends on which direction that you're going from. You can see a little bit sedimental area right adjacent to Saskatchewan River, because you guys may not believe, but our land was entirely submerged by the water, sea. Water flow and deposit play a huge role, as I mentioned. If you look at my diagram on the right side, if you go around the corner and then if it's outside of the circle, you are cutting more and more because you have a lot of speed. On the other hand, when it comes to inside, it's actually quite slower. So what they do is they deposit more. So that's why you see a lot of deposit on the corner that is close to this side. A flood plain is a high water level caused by the extra water from melting snow and heavy rain. This is one of the main reasons why global warming causes a lot of problem when it comes to freshwater situation, because we want to use fresh water, but if this speeds up, then well, naturally we will not gonna be able to use fresh water for humanity. And this extra water flows erodes the stream and riverbanks. And sediment deposits are left when the water levels return to normal. We are almost complete, so let's focus on here a little bit. Eroding away or cause of erosion is something that you may want to know too. So what makes erosion happen? The very first one, when it comes to Alberta, at the Rocky Mountain situation, glacier play a huge role because of melting and freezing and so on, and glaciers also move because of gravitational force too. Like I mentioned, gravity, wind, water, even erosion have two different types. Something that takes longer time, something that takes shorter time. Gradual erosion, a good example is glacial erosion. As glaciers get more snow deposit at the top, it actually moves a little bit too. I'm not talking avalanche per se. Avalanche is some kind of sudden erosion effect more, but while it's moving centimeter by centimeter, ice and snow can do erosion to the structure of the mountain and below. The sudden erosion is what you see on these two diagrams. One is flash flood. It happened with the extra amount of precipitation, and if the land has happened to be next, or if the land is more bowl shaped, like Calgary, this can happen. Landslide or mudslide that can be caused by gravity. Think about a few years ago, California, after the mountain fire, we had a mudslide. And rock slide also can occur too. So today's to-do list is this. I want you to go to Google Class to do Exaslip. You don't have a homework for the weekends.